Assalamu alaikum. We are going to continue with the same topic of compaction, and in today's class we are going to talk about how to determine the density in the field when we are compacting the embankment. Uh, then how we are going to make sure that the density we are achieving that we with reference to the standard profit test. So mostly what we do is we take soil from the field from the borrow area, and we perform what we call it standard Proctor test. And in the standard Proctor test we are going to get what is gamma d maximum, and then what is the optimum water content. So this is our reference values. Whatever values we get, this will come from the lab. So from the lab we get these values, and we try to achieve these densities in the field. If we can attain the same density, it will have 100% compaction, but mostly we can get up to 95 or 98% compaction. So it depends on the requirement of the design. So when we are going to place these layers, so these layers are placed, uh, the thickness mostly is going to be maximum maybe 6 inches. It depends on the type of material, but it might range from 4 to 6 inches. So if this one layer of 6 inches is placed, the rollers are going to be used. When this layer gets compacted, then we have to do one test, what we call it field density test. So we have to check whether we got the required density or not. So for that we are going to do field density test. So field density test on this layer. Now we will get that test will give us gamma d of the field. After getting this density, we are going to check what percentage of compaction we got. So gamma d of the field divided by gamma d maximum, this is what we get from the lab, and then we multiply it with 100 to get percentage. So this gives us percent compaction. So this gives us percent compaction. So if the project requires that the percent compaction should be 95%, then this should be achieved. If 95% is not achieved, if it is 90% or 85%, it means the soil is not properly compacted. So you have to compact it again one more time, and you have to repeat this test. So once this test is going to pass, we achieve the required compaction, then the next layer is going to be placed. So after compacting this layer, we will perform this test. When this test is going to achieve the percent compaction, we are going to place the next layer. So this process is very slow, and it keeps on going, and this is how we are going to lift upwards. This is how we are going to lift upwards. So this is how the fill is compacted. This is how the embankment is compacted. So today in this class we are going to look at how to find out the field density test. So this is also called sand replacement test. These are the apparatus that we are going to need for this test. So let's look at these apparatus one by one. So this is a standard mold. Remember, this mold is 4 inches dia, and this is the same mold that we use in a Proctor test. This mold is it has a volume of 943 point something, so we can say 943 cubic centimeter is the volume of this mold. Why we need this mold? Because we are going to need this to calibrate, to find out the density of the sand. So this is for calibration. What is the calibration? Calibration means to find out the unit weight of sand that we use in this test. Okay, what is the test? The test is we excavate a hole in the compacted layers. So this hole mostly is going to be of almost this should go up to the thickness of the layer, or maximum 6 inches, whatever is feasible. The soil will be removed from here. So the soil has to be removed from here. So when this soil is removed, Then we are going to place the equipment. So this equipment consists of there's a cone shape here. I will show you. This is that cone. This is that cone or funnel. Also we call it funnel or cone. This is a cone, and this cone has a valve here. You see, this is that valve here, and then on top of it is this jar, a big jar filled with the sand. So this is filled with sand. So what we do is we are going to open this valve, sand is going to fall down, and this sand is going to fill this whole area. So how much sand is required to fill this area, we can easily determine. And what is the density of sand, that is also known. So from there we can find out what is the volume of this hole. If we can know the volume of this hole, then we can find out the density of this compacted soil. So the process I'm going to discuss here, and then we will do one example. Okay, so this is that cone, and this is that jar. This is the same jar I'm talking about. Okay, so this is that concept here. The when this valve is opened, the sand is going to fill in this hole, and also this sand is going to fill in this cone. So how much sand goes into this cone, we can easily determine it before starting the test. How much is the weight of sand inside the cone? Then we can find out what is the weight of sand inside the hole. So if you know the density of sand, the sand that we are using in this case, mostly we use this sand, but if it is not available, you can use some other sand. So remember, the unit weight of sand is going to be equal to the weight of sand in the hole divided by the volume of the sand inside the hole. So we know this gamma sand from the lab. This is what we know it, and we also can find out what is the weight of sand inside the hole. So from there we will get this volume of sand in the hole, and that volume of sand is going to be the volume of hole. So this is how we determine the density. So let's look at the process. The first step is to calibrate the to find out the unit weight of sand. So what we do, the first step is to place this mold and to get the empty weight. So if you focus here and observe, the empty weight is given. So then we note down this weight. Then we are going to fill this mold with the sand that we are going to use in this test, and this height of drop, this height of drop, it should be same as the height of cone. Height of cone. So this is that height of cone we are talking about, this cone, this height. Okay, so that we have the same effect of compaction. Now once this gets filled, we are going to remove the excess sand, and then we are going to do the weight again. So this weight, now this is modified. This is the proctor mold filled with sand, and with excess sand is removed from top. Then the next step is to place it on the weighing scale and get the weight of mold plus sand. So this is W2. So W2 minus W1 will give us the weight of sand inside this mold. And we know what is the volume of this mold. So we can easily find out the unit weight of sand is going to be equal to W2 minus W1. This is the weight of sand inside the mold divided by the volume of mold. and remember the volume of mold is 1 by 30 cubic foot or 943 cubic centimeter. So this is how we are going to determine the density of the sand. Okay. Once the sand density is determined, next step is to find out how much sand goes into this cone. So for that, we are going to fill this jar or gallon with sand. We will place this the cone on top of it, and we are going to do the weight. We are going to note down this weight. So this weight is going to be W3. Then the next step is to close the valve, and then we are going to place it upside down and we are going to open the valve. So when valve is going to be opened, the sand is going to fall down and it is going to fill this cone. So this sand is going to fill this cone. So sand will fill the cone. Okay, after we are going to wait almost 2 to 3 minutes when this whole the cone is filled, and in that time we are not going to apply any energy. Let it fall under the gravity. So once this has been done, we are going to close the valve, we are going to remove it, and we have to do the weight again. So that weight is going to be W4. So from W3 and W4, we are going to get out how much is the weight of sand inside the cone. So weight of sand inside the cone is going to be equal to W3 minus W4. W3 was before the opening of the valve, and W4 is after the sand has filled this cone. Okay, now we are ready to go out for the test in the field. But before we go outside, we have to fill this plastic gallon or jar again. This gallon, we are going to fill it again with the sand. We will place this cone on top of it, and we will do the weight again, and that weight will be W5. And we will report all these things on a table. We will see it at the end of that table. Then we go to go to the field. Normally we go to the compacted layer where the compaction is being done, but here in the university you will go outside somewhere and you will choose a location where you want to do the test. So then we are going to place this metal plate, and this metal plate is secured through these four. If you look here, these four holes. So sometimes we are going to use nails to make it fixed, and then the soil will be removed from this. So we are going to excavate soil from here, and the depth is going to be almost, it should have a uniform hole, and this should be at least, if we can go up to 6 inches, it is going to be better. Okay, next we will excavate anything from here, and then we are going to put it in a plastic bag. So keep on excavating and keep on putting in plastic bag. Why we are putting it in plastic bag? Because we want to know how much soil is coming out of this hole, what is the weight. And remember, this soil is going to be moist, so you have to do weight after the test. So if you don't do the weight, then moisture may change and the results are not going to be perfect. So after finishing this test, the very first thing you have to do is you have to find out how much soil has been excavated from this hole. So anyway, whatever comes out, we are going to put it in the polythene bag. Now the test hole is ready. We are going to place this apparatus. We will open the valve and let all the sand fall down. So you remember at the start of the test, you can see very easily here this whole jar, a gallon, is filled with sand, but after some time you will see this is the line of the sand. So this whole sand, this over here is no sand here, because all that sand has gone into hole and into the cone. So after finishing the test, we are going to close the valve, we are going to remove this gallon, and we have to do the weight again. Okay, we will do the weight again. This will give us the weight after the test, and then we will bring all that soil from the hole, and we are going to do the weight of this soil that we excavated from the hole. We are going to put this soil into the oven to find out the water content, and then we are going to report all this data on this table, and from there we are going to find out what is going to be the unit weight. So the unit weight of this soil was 1561 kilogram per centimeter cube, or you can write it 1.56 gram per centimeter cube. This is also same as 1.56 grams per centimeter cube, or this will also be, you can convert it into kilonewton. So into kilonewton is going to be multiplied with 9.81. So this density is 15.3 kilonewton per meter cube. And we find out the moisture content, and moisture content was 4.76, and from there we find out the dry unit weight, which is 1.49 grams per centimeter cube. So this is how we get this this test result, and this gamma D will be called as gamma field. Once we get this gamma field, we are going to divide it with gamma D maximum, which we got from the lab, and then we are going to find out what is the percent compaction. So this will give us percent compaction. Okay, let's do now the test. Now let's do the example. Here's the data available to us. That was a test was performed, and then we got this data. So let's go through this data. During a construction of a soil embankment, a sand cone in place unit a weight test was performed in the field, and we obtained the following data. Number one, mass of sand used to fill the test hole and cone is 867 grams, and the mass of sand to fill the cone is 319 grams. The unit weight of sand is given, but the units are different. The amount of soil that comes out of the test hole is 747 grams, and the water content of this soil was 13.7. So we have to find out the dry unit weight that we achieved in the field. So let me first sketch the problem here. So this is that compacted layer. We excavate a hole here, okay, and then we place on top of it the apparatus. And there's a valve here. Now the question says the mass of sand used to fill test hole and funnel, means the sand that is going to fill this funnel and test hole. So this hole, this yellow, is actually the weight of sand in the hole plus weight of sand in this cone. How much is this? It is given here in number one. The mass of sand used to fill test hole and funnel. How much is this? This is 867 grams. So 867 grams. Now the second thing is the mass of sand to fill the funnel. So it means the weight of sand in the cone, only cone, is 319 grams. And one more thing is how much is the soil that was excavated from here. So the mass of wet soil from the test hole. So the weight of soil from this hole, how much is this? This one is 747 grams. So how we can find out the unit weight of the soil? So first we have to look at what is the volume. So if we can find out the unit weight of soil, it will be equal to the weight of soil divided by the volume of soil, and we are excavating it from the hole, so we are talking everything with reference to this hole. Now the volume of soil from the hole is already known to us, which is 747. The only problem is to find out the volume. How to find out the volume? So in order to find out the volume, we are going to use this unit weight of sand, and we know unit weight of sand from lab. This is going to be equal to the weight of sand that goes into hole divided by the volume of sand that goes into hole. Now the unit weight of sand is given, and the volume of sand inside the hole we can also find out. So look here. So the weight of sand inside the hole is going to be equal to, you have to subtract these two. So let me call this as 1 and let me call this as 2. So when you are going to subtract 2 and 1, so when you subtract this 2 and 1, so from 1 and 2, what we are going to get? The weight of sand in the hole, and that is going to be 867 minus 319. So 867 minus 319 is going to be equal to 548 grams. So and unit weight of sand we have to look at. So this is going to be 548 divided by volume of sand in the hole. Now everything we are dealing is with the grams and centimeter cube, but the unit weight of sand was given in a different unit. So let's first convert this. So if you look at gamma sand given in this problem is 98 pounds per cubic foot. So this is 98 pound per cubic foot. So we have to convert it back to the consistent unit. So you can convert it very easily. How? This is the conversion unit. We know that the unit weight of water is 62.4 pound per cubic foot, and this is also equal to 1 gram per centimeter cube. So from there we can find out this. This is actually the relationship to convert. So it means 1 pound per cubic foot is going to be equal to 1 over 62.4 grams per centimeter cube. So if you divide this, gamma sand is going to become as gamma sand is going to be 98 by 62.4, and units will be now gram per centimeter cube. So if you calculate, this will come as 1.571 grams per centimeter cube. So we got the unit weight of sand. So let's now put the values here. So it is going to be 1.571. So if you simplify, the weight of sand in the hole is going to be equal to 548 divided by 1.571. So 548 divided by 171 will give you 348.8. 348.8. centimeter cube. So now we know the weight of sand in the hole, and that is the volume of sand in the hole. So that is actually the volume of hole. So from there we can now put it back to the formula. So that unit weight of soil should be equal to the weight of sand inside the hole. We know it already. This was 747, and the volume of hole is 348. So when you calculate, this will give us 2.14 gram per centimeter cube. Okay, so gamma soil, this is the moist soil with moisture in it. It is 2.14 gram per centimeter cube, and the water content was 13.7%. So 13.7% is 0.137. So when you put it in the formula, you are not going to write 13.7, but 0.137. So what will be gamma D? Gamma D is gamma over 1 plus water content. So this is going to be 2.14 divided by 1 plus 0.137. So this answer is going to be 1.88 gram per centimeter cube. Now we can summarize our results. So gamma D is 1.88 grams per centimeter cube, or you can convert it to kilonewton. And remember how we are going to do this conversion. You know the unit weight of water. Unit weight of water is 1 gram per centimeter cube, and in kilonewton it is 9.81 kilonewton per meter cube. So this becomes your conversion, and also 9.81 kilonewton per meter cube is 62.4 pounds per cubic foot. Or there's a third conversion, is 1 gram per centimeter cube is 62.4 pounds per cubic foot. So any conversion you can do. Okay, so anyway, so if we convert this, so this 1.88 is going to become, so this is going to become 18.44 kilonewton per meter cube, or if I convert it back to pounds, so this is going to be 117.3 pound per cubic foot. So whatever unit is required, we can convert it. So this is how we get the data from the field, and we find out gamma density, gamma D of the field. So this is gamma D of the field, and this comes from field density test. This is also called field density test. This is called in situ test, or we also call it sand pond test or sand replacement test. So this was all about this chapter of compaction. So with this lecture we come to end of this chapter, and in my next lecture I'm going to start with the seepage analysis, or the water in the soil. So please, when you watch these lectures, please make your notes and note down important points. Thank you so much, and have a great day.